No more lip syncing, right? Thank you very much for the intro. My name is Walid Negm again, and I am dialing in from a little bit of a dreary weather here in Washington, D.C. I am the CTO of Aricent. I'll tell you a little bit about the company in a moment. I'm responsible for our technology strategy and our offerings, as well as our innovation agenda. With nearly 2/3 of the world's 7 billion people already connected, most of them by smartphones, I think we pretty all know that the next big opportunity for businesses and for us as a society is trying to figure out how to create a new type of relationship between man, woman, and machine, and take advantage of all those physical objects that are not connected, whether it's for sustainability, waste management, driving new and interesting revenue streams for companies. The real big opportunity is the connections between people and things. And I was told yesterday that the subscriber base in India, in particular, is about 1.25 billion. Out of 1.25 billion, is about a billion strong subscriber base, mostly in the telecom and mobile sector. I think when you look at that number, you sort of have 250 million people left. You sort of try to put into perspective what are telecoms and software companies and chip makers eyeing as the next big thing. Certainly a big challenge for the telecommunications sector is the infringement, the blurring of industry boundaries, and the distribution of value in certain ecosystems is changing. In the automotive sector, for example, who gets the largest share of a connected vehicle? Or in a home setting, where you have vendors that are offering smart thermostats, opening and closing of garage doors, who gets the fair share? So there's a lot of interesting things happening in the ecosystem. What we thought we'd do is we'd take a look at our customer base and what's happening in the telecommunications and networking sector, and we've developed what I call a point of view around embracing digital durability, and you'll find the extended white paper online. This particular section is around conventional connectivity, which I'll go through right now. But again, just to briefly touch upon Aricent, again, I won't drill down too deep, but Aricent sometimes is the best kept secret. It's a company with a 25-year history. Actually, our origins date way back to Hughes Network Systems in about 1991, where we set up to help solve pretty challenging satellite communication issues, latency issues. And then since then, we've evolved through acquisitions, through investments in capabilities. We've actually grown to be a company that from the customer to the chip. So we are a global design and engineering company. For the digital era, we help pioneers themselves figure out how to create new and interesting customer experiences, how to connect systems, and certainly we work at the chip level. One of the most interesting parts of Aricent, and it goes into unconventional connectivity quite a bit, is that we own a company called Frog. So Frog Design is a strategy company. They have design houses, locations across the globe, and they originally began in Silicon Valley. Steve Jobs asked a gentleman by name is I think his name is Harmut Esslinger to design his computers, and we came up with what's called the Snow White design. And since then, we've been working with brand names around the world through about 600 strategists, researchers, and designers. This is really important, actually, because when you think about connectivity, a lot of times you want to ask the question, why? Why do I want to connect? Right? Why do I want to have a smart helmet? What does it mean to be able to control my car to control my home appliance from my car? So a lot of interesting questions happen early on in the design phase, where you're doing behavior analysis and understanding what's the magic moment really behind connecting physical objects and things. So customer experience plays a lot in this particular conversation as well. We talked about customer to chip. This is our capability map. I just throw that out for folks to get a little bit familiar with Aricent. We function as a design and engineering company, helping think through the relationship between humans and physical things, and actually digital experiences as well, all the way down to driving outcomes. I'm going to skip over this. It'll be online as part of the recording. We're a product lifecycle services company. So we go from design all the way to support services. We work with a number of industries, telecommunications, certainly, software companies, semiconductor companies, chip makers, and we solve problems across the life cycle, but also some of these interesting pressing challenges in these technology domains. So that was the setup of Aricent. It's important just a little bit know where we're coming from. The trend that we're going to be talking about today is called navigating unconventional connectivity, but it's actually set up as part of a broader conversation around what we're calling digital durability. And I don't know if anybody was watching the news yesterday, but Amazon is entering into yet another market segment around Amazon Video, Direct, I think it's called. So it's kind of competing a little bit with YouTube. Certainly, there's a streaming component there, and it touches upon connectivity. But the key point is that Amazon sort of has got it figured out and how to generate some pretty lucrative offerings. And so offering after offering, they do some experimentation, but they do come across some pretty significant wins. And we've done some research to try and figure out what are the patterns behind companies like Intel, Google, General Electric, to some extent, of course. In the industrial sector, the growth is not as significant as other sectors, but there's a durability about GE, right? And there's a durability, so to speak, about Amazon. And it comes about by really thinking how to anticipate disruption and how to transform processes to compete on what's been called for the last decade or so outcomes. And so simply closing this digital gap is no longer sufficient. The engineering team, the design team, the senior leadership really has to come together and figure out how do I get those sustainable value creation opportunities. It's really a product management. It's a go-to-market question. And we've identified, not like other research reports, but from an engineering perspective, from an R&D perspective, these are the 4 trends that our clients have been looking at and continue to look at very carefully. So driving smart outcomes, designing for hyperscale, recognizing the value of the chip and the substrate, systems on chip and silicon, but also going beyond that into finding value in algorithms and finding value in ecosystems. And certainly for the topic today is navigating unconventional connectivity. So in context, this is really how do you look at the driving forces behind connectivity, what are the scenarios that are unfolding, and how do you anticipate disruption? We're not going to dig really deep into the engineering, although towards the end hopefully we'll get some interesting technical questions. And my colleague Abhijit Josh will help me navigate those. So what is navigating unconventional connectivity all about? I think part of this is really that the playbook for connectivity is still under construction. I think a lot of times we get wrapped up around the scale, if you will, and the number of people connected, but there's a lot of geographic real estate out there that is unconnected. There's a lot of scenarios and use cases that simply won't work with a traditional telecommunications model, either from a cost model perspective or from a technology perspective or from a design and experience perspective. So I think when you look at a scenario like a vehicle that's in a parking space and is looking to interact with a pole or a traffic light, but also interact with somebody wearing a wearable to find out maybe there's a geofencing scenario or you're simply trying to locate your vehicle, maybe you want to turn it on remotely. You don't jump right away and say, well, I'm going to go and use LTE, right, or 3G or 2G as part of the engineering specification, right? There's some interesting questions that you have to ask from a device level perspective, right? What's the performance characteristics that you want on the wearable to be able to support that sort of communication? There are new standards evolving for vehicle-to-vehicle connectivity, vehicle-to-infrastructure connectivity. There's beyond the power, there's certainly spectrum questions and things that are playing out in the telecommunications industry in terms of narrowband IoT. So the playbook for sure is still under construction. In the top right-hand corner, you see maybe not in the case of an automotive example, but certainly companies like Google and Facebook that are embarking on pretty ambitious alternatives to connecting rural populations as well as also probably industrial complexes and industrial assets that are far-flung and too remote from base stations, creating base stations in the sky through balloons and drones. And then that chipset on the far right-hand corner actually is a company called Proton, I believe, and they produce essentially a module in a small packaging that can be embedded into all sorts of devices. The interesting thing about them is the business model. So they're trying to figure out how to make it worthwhile to connect over existing infrastructure for the telecommunications companies. So pretty much, you know, an open playbook. Things are moving quickly. It's a very interesting space. You know, when we talk about navigating unconventional connectivity, some of the things that I touched upon just a couple of seconds ago really start to come to life when you think about V2X and vehicle to infrastructure. This is an example of intelligent traffic management for emergency vehicles. And you know what's happening here, you see that the tier 1 suppliers and the auto OEMs are investing in their own technologies, right? And so they're thinking about what it means for their vehicles to have this type of onboard systems. And there's an impact on the telecommunications sector, right? The relationship between these OEMs and the value proposition, you know, is something that's still sort of unfolding. There's governments and municipalities that need to be part of this discussion. I think the broader implications certainly are not to look at the vehicle as a just purely from a safety perspective for an individual or for a collective, right, for a setting like this, but from an outcomes perspective, right? And how do you capture the carbon emissions and participate in programs as you enter and exit, say, the City of London, right? To be able to instrument these machines and then feed them back to a broader storyline is really an interesting part of why unconventional connectivity is going to have such an important economic outcome in and of itself. So we encourage, you know, our customers, our clients, to think about the outcomes as much as, you know, the technology that's connecting all of these things together. But there's a lot of, you know, when you dig behind the layers here, there's certainly a lot of dynamics. I think Intel is a participant in the ecosystem, but in the automotive sector, you know, it seemed to have pulled back a little bit, right? And so they shut down a number of SOC programs in the automotive sector. So when, you know, whether you're a telecommunications provider, whether you're an end customer, there's so many moving parts, right? And you don't want to down one road where there's a particular investment in a chip maker's roadmap and have yourself locked in to that particular set of standards. And so you do have to be very, very agile in this particular trend, right? In all these trends. But I think unconventional connectivity, you're thinking beyond sort of 3G, 2G, UMTS, and you're trying to anticipate standards that may have not gelled yet. So, you know, when I think of unconventional connectivity, a lot of folks ask, you know, what is unconventional connectivity? What is unconventional about a hard hat, right? I mean, I think that certainly if you use Wi-Fi in and of itself may not be unconventional. You know, if you think about using Citizens Radio, maybe that's not unconventional. You know, but I think the experience is unconventional, right? I mean, it's not. It's maybe 5 or 6 years old that we've started to talk about smart wearables, but the experience is not something that, you know, necessarily everybody is used to have a completely sensor instrumented helmet. And so I think you really have to think about connectivity and unconventional connectivity not simply from a technology perspective, right? Whether we are going to use narrowband IoT or Wi-Fi is part of the discussion. But I think you really encourage our customers to think about the entire customer experience of the helmet in this particular case, right? And so this particular helmet was actually designed in conjunction with Frog, and we thought about clunkiness, convenience, we thought about safety, and then of course we thought about connectivity in a factory setting, right? What is the pervasive wireless environment at a particular oil refinery? What are the additive ingredients to create a mesh network? And certainly some of these mesh routers need to be hardened. And so security is certainly an important part of the conversation. And how do you harden an industrial-grade router that has firmware on it? You have to have over-the-air updates. And so when we have a conversation about connectivity, it's absolutely about a system of systems conversation. It's not simply about these standards that are yet nailed down, like from 3GPP, but about the system of systems. So everything has to work together seamlessly. So we talked about unconventional connectivity as certainly being part of an unfolding narrative and standards in use cases, and that certainly customer experience is a paramount part of the conversation. So we've identified 3 scenarios that are unfolding in parallel, really, when we think about unconventional connectivity. And I don't think it's a binary response to some of these questions, right? The first is around whether open standards or open connectivity versus a much more closed, sort of garden option. Right? We think a lot of the times about the telecommunications sector being part of that, and it's not necessarily a pricing thing. It's just simply how do you get in and out of the relationship, and it's about convenience, and it's about flexibility. And so unlock the box, for example, here in the United States, which is it's legislation now that cable companies cannot completely own the CPE, right? The consumer premise equipment. The set-top box has to be made available in an open hardware fashion. So I think unlock the box is an example where where we think is openness the way to go, and how will that evolve. So I think that in different sectors there's going to be a different answer for this. In industrial scenarios, you need industrial Ethernet, and you need to be able to rely on carrier-grade reliability. In a connected home, you find that there are startups coming out every 3 or 4 days with a connected device that allows you to turn on and off your home gadgets. The issue there is that these startups can fold pretty quickly, and certainly security is an issue. I think only recently Nest announced that it's shutting down one of their connected home hubs, leaving a lot of customers, or some customers, high and dry. What you're seeing here in front of you is actually some work we did with a large furniture company, furnishing company, very, very large, begins with the letter I, and they've been entering into the connected home slowly but surely. And so this project was, simply asked the question, what does it mean to have a home that is sort of at the disposal of the homeowner, right, and not vice versa, right? So what are the convenience elements? What are the customer convenience elements? And so the lighting switches may be a little bit different in this scenario than something that may be a brute force using a smartphone, right? When we design for customer experience, usually the HMI changes significantly, and new types of experiences emerge. Right? So I won't go into the details, but basically, I think this is an interesting space where a lot of things are happening. Certainly, we see unlicensed spectrum as an important part of the conversation in the connected home. I think it's not necessarily always the answer, but the coexistence of Wi-Fi and LTE in the home is certainly a big part of what we define as unconventional connectivity. Although it's more likely that you see these types of coexistence happening in venues and places where you do need the extra capacity, right? You do need the extra spectrum. So in a home, I think coexistence maybe is around Bluetooth and Wi-Fi and some of these other standards versus necessarily LTE. Another example of, I think, unconventional connectivity that just begs the question more than the technology is why, right? I saw this example, connecting the home appliance from the car, and I think here there's a ton of protocols right? But I think the real question to me when I think about connectivity a lot of the times is why. Why do I want to do this? Certainly how is an important question as well. But why on earth do I want to control my dishwasher for my car? Now you can, but it's about feature, I guess, a feature creep, and trying to solve a real problem versus just being able to turn on and off something. I guess again the key message here in terms of will openness win is certainly a lot of it has to do with the customer experience. There's certainly a pricing and business model conversation to be had here. There's certainly evolving and emerging standards. So it's not a binary answer, yes or no. It's more about keeping track of the new standards that are emerging. I think a lot of the interesting open standards or open alternatives are certainly happening in the industrial sector with companies like Sigfox and low power wide area networks like LoRa, and whether they could be of value in scenarios like the ones here, right? Street lighting and car parking versus in the home. We'll touch a little bit more on that in a bit. That's the first sort of scenario that's unfolding. The second scenario that's unfolding is this idea that nothing is going to change really. That the de facto wide area radio network today is a cellular network. It works fine, and there'll be modifications to LTE, for example, to support machine to machine. And so the modems today that they're out there could be retrofitted pretty in some cases in a straightforward manner. In some cases you need new hardware, but the spectrum is out there. It's available. It's reliable. It comes with service levels, quality assurance. It comes with security. There's really a lot going for the existing model. Certainly power is probably the one that comes up a lot, power and cost overall, the business model. But here's an example of where LTE is being used in a little bit of an unconventional way or in a different way. We're used to small cells being a tool to provide extra coverage and additional capacity and venues, for example, and the backhaul is fiber or the backhaul to the core network is cable, right? This particular case is just simply the backhaul is LTE. So the value proposition is for rural settings, and you acquire either through the telecom partner or through a retailer an antenna. You install the antenna on the wall, and you have a home router, and you use the existing rural cellular network infrastructure. So the unused spectrum in these rural areas is actually significant versus a highly densely populated area. So here's an example of where it's the dominance of carriers and ownership of spectrum plays in their hands, right? And it's whether the adoption is significant or not is certainly a matter of more go-to-market, but the technology exists to use LTE here in a little bit of an unconventional way. I think in terms of where the telecommunications sector is headed and where the opportunities are, I think there's two areas I think that are pretty exciting. Certainly the march towards 5G, where you could do some interesting things in the cloud as opposed to on board in an automotive setting or even at home. And so the analytics can be done in a remote setting far away from the actuation, but the latency requirements need to be there in order to accomplish so this very real-time response. This scenario here, you have an individual who is being informed whether they're distracted or not. I mean, today you do a lot of onboard processing. Companies like Mobileye and others allow you to do lane departure warning from vehicles, but there's certainly an opportunity with 5G to do a lot of that heavy lifting in the cloud. And it's a big opportunity for telcos, big opportunity to be able to be part of these new types of scenarios. Certainly in a vehicle or in anywhere else, 5G is going to be helpful for very data-hungry applications, video streaming, teleoperations, and such. So I think the telecommunications model has sort of this unfair advantage as 5G approaches. It's not here yet. And I think the answer for them is going to be continuing to be part of the ecosystem, right? Continuing to find a really good relationship between automakers, industrial OEMs, and because connectivity is just part of the ingredient. Right? There's a lot of software involved. Companies like AT&T and Verizon retooling their entire workforce just to be able to take advantage of the value creation opportunities. And software is admirable and it's a must, but I don't think I think it takes a community. Right? It takes a community. It takes a collective to be able to be successful in some of these industries, whether it's smart city, smart communities, in an industrial setting, industrial complex. So besides enhanced mobile broadband and sort of this type of high data hungry, I think certainly the telecommunications companies that own spectrum have an interesting opportunity to take advantage of their spectrum for less data hungry applications as well, which we'll touch upon in a bit. So those the first sort of scenario that's unfolding is this idea of openness will win, or there's an advantage there to being open and using things like LoRa, Sigfox, unlicensed spectrum, and the coexistence between LTE, finding solutions there. And the second was around the dominance of telecommunications, the sort of the orthodoxy that exists there, and then certainly the third is the blue ocean thinking that's happening. And this is sort of the most eye-shocking example, right? I suppose, where the future is being engineered, at a daily basis by software companies. And in this particular, I think this is the image. Maybe this is about Project Loon, but providing these radio base stations in the sky is a very it's a groundbreaking, unconventional way of connecting people, connecting things together. Facebook has a similar program where they're in a remote area. They're making available a base station in a box, and you should drop it. I think it uses maybe 2.5G, if I'm not mistaken. And just looking for the time, make sure I'm on schedule here. So unconventional connectivity, I think I really think that the interesting thing here is the business model. Right? I mean, how do you make something like this work? Right? And how do you create a pricing scheme that works? No doubt that the engineering is phenomenal, right? And no doubt that the technology is phenomenal. But you really have to talk about those two together, and the viability of something like this. But back to digital durability, right? Without experimentation and without participating in these types of projects and programs, a lot of companies are going to be left behind. And so these low Earth orbiting satellites, backhauling, whether it's 2G, 3G, 4G, data traffic, is only achievable by a certain number of companies, okay? And breaking an industry that has sort of done well at taking advantage of spectrum is not easy, right? In this case, though, that the telecoms certainly are participating, right? They're part of the equation, but the value distribution is changing. Right? The value distribution is changing. There's new participants that have a little bit of a bigger stake in the relationship and the control point to the customer. So Google here, Facebook, and others certainly are able to offer a different type of experience for customers. So cell towers in the sky, very unconventional, very interesting from a business model as much as an engineering perspective. Here I think this is sort of an amalgam. We talked a little bit about venues and how a venue can be, the capacity in the venue can be extended through cells, but also there was an example earlier around LTE as the backhaul. The middle example here is a smart meter. I think here the discussion becomes interesting again around low power wide area networks, and we always like to think about that the future of the Internet of Things is going to be in billions and billions of devices, but it is worth pondering a little bit around whether it's going to be a lot of people sucking up a lot of data bandwidth. I think it's back to the long tail of innovation. There's going to be a lot of interesting applications and a lot of big juicy ones in this long tail innovation, and certainly the winners and not so are the ones that are able to spot those and sort of hold on tight. But smart energy is a very attractive area. There's certainly bets to be made, right? You bet on somebody like a Sigfox, or you bet on another low power area network, and lo and behold, narrowband IoT comes along. Is that, as some would suggest, a death nail for some of these new networks and their business models? Okay. So being able to figure out how to remain agile to these changes is going to be pretty important. So I think that's the bulk of the trends that I wanted to talk to you about. I didn't want to dig too deeper into some of the issues that are happening in license exempt spectrum. We certainly will we'll take some questions and try and field them. But we wanted to paint a picture of three of the most important scenarios that are actively unfolding, and some of the use cases that we see are pretty unconventional, that soon may be mainstream. The key takeaways, I think, that I'd like to leave you with, one is, yes, from a technology perspective, the field of play is expanding, right? And for everybody, right? For service providers, for equipment makers, for software companies. And so from next-gen wireless perspective, there's a lot of work to be done in just simply sustaining 2G and 3G networks and transforming them, over time. 4G LTE is not mainstream in certain countries, and there is product development realization that has to happen there. 5G and the evolution towards 5G, things move real quickly. I mean, I am, by no means the expert in 5G, but I have, one day you'll hear about a particular technology roadmap, and so you close your eyes and open them, and it's arrived. So things move really quickly. The pace of things is important as well, for sure, but 5G will be here in no time, and so I think there's a question around how to experiment and how to be part of what's happening in test beds, interoperability, figuring out the use cases, doing strategy work around the customer experience. So it's certainly worthwhile to get a head start there. I think we also underestimating what's happening behind the scenes a little bit when we think about connectivity. Designing for billions of things is not the same way as as a mobile app, right? These are applications that have different communication characteristics. There's messaging protocols that are maybe a little bit more reliable. There's layering of technologies that actually you think you're getting 1 millisecond response time, but by the time you're done with the different technology stack, north and south, you end up with certainly a very different type of profile. So I think thinking about what happens in the back end in terms of the data center and the infrastructure is a very important part of the conversation, and software-defined networking, virtualization of the packet core from a telecom perspective, but also from a service provider perspective, is certainly an important part of this field of play. And then finally, I would say that the idea of that IoT is going to drive significant revenue growth, and we're all bought into that. One of the linchpins is just getting the use case right. And so again, back to that long tail. It's attractive to think about smart meters. It's attractive to think about automotive. It's attractive to think about smart buildings. But when you think about how do you make money selling gear that costs a certain amount of money, you have to be able to think unconventionally. You can't just say I'm going to go at it the same way. And so whether it's new financial models, or whether it's packaging of the data plans and breaking that model up entirely, I think this is certainly an important part of the conversation. So that's it. This is a takeaway from the takeaway. But focus on experience. Understand the gap between IoT readiness and reality. This was, I think, a very interesting report Accenture put together a while back to suggest it. That was about a year back. That there's simply a lot of enthusiasm, a lot of energy around IoT and connectivity of things to people and machines. A lot of interesting conversations around the relationship between man and machine, whether it's an industrial setting with robotics, it's a smart meter, whether it's a backhaul LTE scenario like Nokia is putting together. But you really have to understand the technology gaps and the business model gaps to really make money in this area. Cloud as the path of least resistance, I think certainly is probably true, especially when you think about 5G with latency becoming what it will be with that technology. You can certainly assume that, but not in all settings you will have an always-on persistent connection. And in terms of real-time actuation and closing the loop real quickly, there's certainly going to be onboard communication. So the car's connectivity fabric has to change as well. And then designing for open and simple hyperscale systems, a big part of the conversation. So that's it for the bulk of the presentation. I wanted to take a pause here and field some questions if there are any. I have my little chat panel here, so we'll see if there's any questions. If not, we'll certainly adjourn. I'll wait a couple of minutes here for some questions to come in.
That's the questions already shared with you.
Oh,
Just to check in the control panel.
I apologize. Okay. Let's see. So we have here one. It says, sort of a little while back in terms of what does hyperconnectivity mean? Is it high speed, and what bandwidth required for intelligent, IoT devices? Hyperconnectivity. I guess I don't know who coined it. It was a while back that I heard of it, and certainly it's everything connecting, everything computing. Certainly, it's about the numbers that are involved. I don't think it's a one-size-fits-all response in terms of is it about latency. If 5G had any number of characteristics as part of the spec, right? Latency was one of them, bandwidth was another one, and I have a GT, you're going to have to help me here, but yeah, I really don't think it's necessarily about a specific profile of connectivity, but certainly it's about scale of the number of connections that are involved. And so we're moving from billions of people to 20 billion devices. I think it's just it's a helpful umbrella term to describe sort of volume. Here I have a question around what is the risk associated with designing these types of systems, and the failure rate? Is there a way to predict the failure rate? I've been involved in cybersecurity. We were in a conversation with an automotive tier 1 supplier, and he was asking about V2X capabilities and how do you connect infrastructure and these units that are going to be and light poles and units. I mean, it's a pretty scary world when you think that some of these systems, some of these products are going to be designed by startups that we don't have any clue around how to do a threat, a threat model. So I think it's really important to be able to understand the ins and outs of this hyper-connected world. And so one of the tools that we just probably have to bring in from the industrial setting and from an enterprise is analytics, right? And so I think the analytics piece, assuming you're compromised, is I think it's an important part of what we have to do in a hyper-connected world. It's a concept that's been around in IT forever, right? Assume you're compromised and try to discover where that where the adversary is hiding and lurking. I think that's really important. Then you can start to do some prediction. And so I would I would say an active defense mindset that's typically been reserved for. We do a lot of hardening, I think, and certifications when we think about things. We think about smartphones, but I would say just overall in a hyper-connected world, you probably should think about taking some of these best practices in the enterprise IT security realm and then map them over to what we're doing here in M2M. Assume you're compromised, and then sort of apply some best practices. So I think those are the bulk of the questions. I'll hand it back to my host, and sort of maybe we can wrap up. I think we're on the dot here. So back to you, host.